Hello everyone, my name is Azam and I will cover the introduction and discussion part. The first problem is this. The first problem statement is the data to be processed is very large, around 70,000, which 60,000 as training data and 10,000 as testing data. Next problem statement is if the data to be processed by machine, it will require proper algorithm and training to ensure relevant output. And final problem statement is for machine learning, there are wide variety for algorithm and method to be selected. For application in this research, the algorithm must be able to fit data and perform classification with high accuracy. As for the application part, the image pattern recognition is mostly used in medical image classification. The X-ray, CT scan, and MRI images can be analyzed and classified by machine instead of depending solely on expert physician. This will save time and money as large amount of data can be processed in at a time, which can produce faster result, and to an extent is impossible to be done by human alone.
I'm Hakim, so I will presenting regarding the methodology about the flows in our making of the digit classification machine learning. First thing first, before we start doing the machine learning, there are a few steps we need to do first. The very first thing that we need to do is to obtain, load, and extract the data so we can understand and see how our data is. In this research, we are able to get a digit data in form of the array that's saved in the MATLAB. But this image data cannot be shown without us to extract it properly. So we use the extract data function in order to see the shape of the digit image. Also in this research, we have 60,000 of trained data and 10,000 of test data, where we will divide it to make it a model. Once we are done understanding our data, it is time for us to pre-process the data, which is in this research we use IM binarize or binarized method to change the gray level of the digit image into the white and black domain to ease and improve the efficiency once we train a model. After we binarize all the image, we can start using the feature extraction or feature generation to extract a feature for the machine to learn. And we use the HOG, or known as histogram of oriented gradient, that capture the image piece by piece and also allow machine to see the magnitude of each part and the orientation of the edge. Once the feature generation has been done of the binarized image, we can start to train a model based on our classifiers. We use 3 classifiers in this research, which is KNN or K nearest neighbors, the decision tree, and the SVM or support vector machines. Once we are done with training a model, we can start do the model testing. And the model testing also have a few procedures. We need to load our tree model, which is we did previously of the KNN, SVM, and tree model. However, we also need to pre-process the test data for us to do HOG again. After we did the feature extraction of the test data, we can input the test data into the model, let the model run the test data, and after the test data have been analyzed, we can see the performance of the model by looking at the accuracy, the confusion matrix, and the runtime of the models. Once we are done with the testing of the data, we can start to plot the result of our data. First thing first, I want to put a disclaimer where this test was done on the laptop with 60 GB RAM, the Intel i5, and also GTX 1050. So the performance may vary on different specs. Continue to our result, which is the 3 classifiers. We can see the confusion matrix at the right side, where this classifier has shown have the accuracy of the 90.3%. Also during the runtime, I recorded is around 1 minute and 27 seconds for whole coding to run 8 model. The memory consumption is 297.8 megabyte. The result loss, or known as the return the substitution loss, is around 0.0229. For the next result, which is the SVM classifier or support vector machine, the accuracy of this model are very great, which is 98.4%, and the runtime is also moderate, which is 2 minutes and 2 seconds. The memory also does not differ much from the 3 model, which is 297.9 megabyte, and the result loss is 0.0024, which is quite low and great. Next is the KNN classifier, or K nearest neighbor. This classifier has a moderate accuracy among three classifiers, which is 96.7%. However, the runtime of this classifier is too long that took 30 minutes and 51 seconds to run the whole coding. The memory of this classifier is not different much from the previous two classifiers, and also the subload is the best among the three, where there is no return the substitution loss at all. That's all for our result.
Moving on to discussion, I will focus more on the performance of the model. There are a few parameters which are used in evaluating the performance of the model. The parameters are accuracy, runtime, memory usage, and resubstitution loss. Among all the models, none of them excel in all categories. However, each model performed their best in a single category. On the right, you see the visualization of the ranking of each model in each aspect. So this is the ranking and how they perform in each of the category. So this is briefly, and moving on to next slide. So in runtime category, the decision tree performed at the fastest time of 87 seconds, followed by SVM at 122 seconds and KNN at 1851 seconds. The KNN performed the worst in the runtime category with time of approximately 30 minutes, thus decreased its appeal as the go-to model. As for accuracy category, the SVM performed the best at 98.4%, followed by KNN at 96.7% and decision tree at 90.3%. In memory aspect, all the models use 297.5 megabyte, thus place them equally or tie. So this category actually doesn't set them apart. So in the final category, which is the resubstitution loss, KNN performed the best with resubstitution loss of 0.0000, followed by SVM at 0.0024, and finally decision tree at 0.0229. With all things considered, the best model is SVM, with impressive performance considering all aspects discussed. As for other models, it is up to the user on which one they prefer. If the runtime is not an issue, KNN is better than decision tree. If the accuracy is not the main issue, decision tree perform better. That's all for me. Thank you.
Last but not least is the conclusion, where from this study, we are able to understand the steps in doing the machine learning, such as we do the pre-processing, the feature selection that we use HOG in this study. And also we are able to test three classifiers that we choose, which is KNN, SVM, and decision tree. And from the result that we did our testing of the three classifiers, we're able to get that SVM is the best among the three because it has great accuracy, moderate runtime, and very low loss. That's all from us. Thank you.